Hello everyone, welcome to Easy Learning. Today we are going to learn about factoring. And like every time, we are going to look into the definition. First, I have a typo in here. So it's going to be definition. Okay, awesome. All right, so what is factoring? Factoring is finding what to multiply together to get an expression. It is like splitting an expression into multiplication of simpler expression. Or we could say what is common between the expressions or the variables or the numbers. So we'll look into a few examples first. Simple one. So let's say if we have 6 and 3 and if we factor it out, so 6 we can simplify it further into 6 is equal to 3 times 2, and 3 is just 3 is a you cannot simplify anymore further. So what is fact common between 3 and 6? Common between 3 and 6 is 3. So if we factor 3 out of 6, we are left with 3. This is a what called factoring. Now if we go from the exponent point of view, let's say if we have x to the power 4, which is equivalent to x dot x dot x dot x, and we have x to the power 2, which is equivalent to x dot x dot x dot x, which we have learned into the previous lecture how it works. So if we look what is common between these two, if we factor x2 out of x4, we are left with x and x, x and x. So this is common between x4 and x2. So our final answer will be x dot x. That's our factored form between x2 and x4, and the final answer will be x to the power 2. So far so good. So it works for both the variables and the number. So now we'll look into few more examples. So let's get started. Sorry about that. So let's say we have something, example 1. So let's say you have x square plus x4y plus x3y2. Okay, let's say this is the equation. So x2 x to the power 2, x to the power 4, y, x to the power 3, y2. So now we want to see what is common between all these three terms. It's term number 1, term number 2, and term number 3. We want to see what is common between them. So let's break it down to make it works, simplify. So x2 we can write it as x dot x dot x, and x to the power 4 we write x dot x dot x dot x, and we leave the y as it is. And for the last one we write x dot x dot x dot y dot y. Okay, so if we look into all the terms after we simplified it, we see x and x. First term also has x and x, second term also has 4x's multiplied, and the third one has 3x's multiplied. But what is common between all three is x and x, x to the power 2. So this is one common factor we have, x dot x. Okay, and after we take the factor out, we want to see what are we left with. So if we take out x, so if we divide all of them by the factor number or the variable, let's say if we divide x dot by x dot, so we will be left with 1. We'll be left with x dot x dot actually let me simplify it here. So when we try to write it into multiplication form, so let's say everything common between all these terms are x dot x, x dot x, and x dot x. So let's take x dot x and let's divide all. After that we are trying to factor it, so we are factoring it out. So we'll have to multiply this with the all the remaining terms inside the bracket. So let's see how it works. So we'll be like x dot x divided by x dot x, x dot x dot x dot x dot y divided by x dot x, and x dot x dot x dot, sorry, it's gonna be a dot, okay, dot y, and we will divide this by x. So whichever whatever the common between all the terms, we take it out, and we want to write it in a multiplication. For to write it into multiplication, we have to divide all the terms with the factor number. In our case, the factor number is x dot x, and we will divide all the terms with x dot x, and we'll get the final answer. Like we have looked into the definition here. Let's go back to definition. Into a multiplication or simpler expression, so we're trying to write it into multiplication expression. So that's why we take that common number or the variable out, and then we divide uh, all the terms with that factoring number, and we try to get that into multiplication form. So let's see what we get left out with x dot x. So we can cancel these, so this will be 1, this and this we can cancel. So will be x dot y, and we can cancel this and this, so we're left with 1x y dot y. So now we are left with x square x dot x, but we know the formula from the previous lecture, 1 plus x2y plus xy square. So after we factored out the x dot x in the multiplication, and to write it into simpler multiplication form, this is how we're going to write it. So it's going to be x squared times 1 plus x2y plus xy squared. And now if we break it again, we'll be having the same thing, x squared plus x4y plus x3y squared. This is, we did not change anything, we did not add anything. It's the same expression like we had in the beginning. This is just to convert that expression, like it was all in plus 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 or minus plus minus, whatever it is. We want to write that into a multiplication form, and for that we try to find the common expression between the terms. That's why we did factoring. This is just to solve for x's and y's. We'll get into that later on, but this is how we do the factoring. This is a simple factoring. We will practice more examples, and we actually don't change anything in the equation remains the same. Actually, we can never change anything in the equation, but we just rewrite the form of the equation to solve it in an easier way. So we'll look into another example, and then okay, so let's say example 2. So let's say if you have x3y x2y2 and x4y4. okay, so in this one we can break it down. It's up to you. Once you get comfortable with it, you don't have to, but I'm going very simplified it just so you understand it. So let's break it down again. So it's going to be x dot y, and this is going to be x dot y dot y, and this is going to be x dot x dot. Sorry about that. So it's going to be 4x's and 4y dot y dot y dot y. So we break down the equation or the terms into simplified without the exponent, and now we'll try to see what is common between them, and then we'll divide by the common factor to all the terms. So let's see. So we see here x dot x, and this one has x. So let's look into the x's first, and then we will look into the y afterwards. So we'll see 1 2 3 x's here. We have 1 2x, and we have 4 x's here. So minimum how many x's we have in all the terms is 2. In each equation or each terms we have at least 2x. So 2x is common between all three terms. So we'll take x dot x, that's common for x's. Now look into the y. We have 1y here, we have 2y here, we have 4y here. What is common between all these in terms of y? At least there is 1y into every equation. So this one has 1y, this was 2y, and this has 4y. But minimum how many y's are there? That's one y, so we'll take y as a factor. Now, like previously, we'll just divide it. So x dot x dot x dot y, and we divide by x dot x dot y. Okay, okay, all right. And the second one will be x dot x dot y dot divided by x dot y. So we are whatever we are multiplying with, we are dividing it the same thing, so it will balance out, it will cancel it out. So that's what tells that we are not changing anything in the equation. So whatever we are multiplying with, we are dividing by the same thing. And this one will be x dot x dot x dot x dot y dot y dot y dot y, and we'll be doing x dot y. Okay, and let's see what we can cancel out. So in this one, the first one, we can cancel out 2x's, and second one we can cancel out 2x's again, we can cancel out 2x's again. So what are we left with? X dot y, and we are left with, oh, and we can also, so we cancel the x, sorry about that, we cancel the s. Now we'll see which y we can cancel. So we can cancel this y. Actually, I will make it a little bit nicer for so okay, so we have x, and then we cancel this x, so we are left with one x, and we are so now we look into the y, so we cancel out this y, we cancel one y, and then we have 4y, we cancel one y from here. So what are we left with? So in the, because denominator will get rid of everything, because that's what we're trying to cancel out, or that's the common between all the terms. So we're in the top, the first term will be left with x, and the second term will be left with 1y, are we left with an y? Yes, we are left with the y, and the last will be left with x dot x, and sorry, and y dot y, we will be left with 3 y's. So if you simplify it, or if we know the exponent multiplication rule, so it will be like x plus y plus x square plus y3. So the common was x square y, and inside the bracket in the multiplication part we have x plus y plus x2 y3. X square, so x square y x x2 y2, then it's just y. Yeah, so now if we break it again, we will get the same thing like we have started from. So we are gonna, sorry about that, so I'm gonna get x3y plus x2y plus x4 y3. So this is exactly same as our equation. So that this part here was just done to write it into multiplication form, the expression that's called factoring. So this is all about it. In our next lecture we'll look into factoring quadratic forms. Those are a little bit complicated, but I would suggest you to practice these at this moment. It could be with the numbers or with the variables. I just explained you here with the number with the variables. The number will be same. Let's say I will just do one more example just to understand it. And this last line, how we get it, x to the power 2 times x to the power 1, then you can add the exponent. That's how I get it. Is all I explained into the last lecture, so I'm not going to go over that now. If you have any question, you can definitely ask me. So I'll do one more example. Ex3, so let's see if we have 3x 2y plus 6xy. So even with those numbers, the coefficients here, will be solving in the same method. So we'll see how to solve it. So first we'll simplify the numbers. 3, we cannot simplify it any more further, so we'll leave it as it is. We'll leave 3. We'll break this x into x dot x, and y we cannot do anything. We'll leave it as it is. And for 6, we can, like we did an example in the very beginning, 6 we can write 3 times 2. That's the simplified version of 6, and then x dot y. So now first thing, we'll try to see what is common between the coefficients. So in both the terms, this is term number 1, term number 2, what is common between them is 3. So we'll take 3. What is common between the x's? It's x. What is common between the y is just y. So 3xy is the factor form, and we'll write that into multiplication expression, and like previously, we'll divide the terms by the factored number or the factor expression. x3 dot x dot x dot y divided by 3 dot x dot y, and this will be 3 times 2 times x dot y, 3 dot x dot, and we'll try to get rid of the common ones. So 3xy, and 3 and 3 is common, so we get rid of that. X is common, we get rid of, so we are left with, and y is common, so we get rid of y. And this one, 3 and 3 is common, x and x is common, and y is common. So what are we left with is, in this one we are left with x, and this one we are left with 2. And again, if you break it, so it's gonna be 3xy dot x plus 3xy dot 2. So we'll be left with 3x1 plus 1y plus dot 2, and this 3 times 2, we can multiply the coefficient first, and xy. So it's going to 3x2y and 3xy. Yeah, so we see exactly same equation we had. So we just even with the coefficient, it works in the same way. This is just an example how to solve with the exponent, without exponent, just with the variable. This is very simple one. Just try to find the common numbers or the variables between 2 terms, 3 terms, however terms it is, and try to extract that, and try to write it down in multiplication. That's the goal of factoring. So like I said, we'll learn more factoring in the next lecture. Thanks for watching the video, and don't forget to subscribe our channel and like our page. Thank you very much.